And we look at the central lowlands. This is just 3 million years ago. We don't see the Great Lakes. We do see down below in the smaller circle the Mississippi River, but the Great Lakes and much of the Hudson Bay up in the Canadian Shield, and the Canadian Shield and the central lowlands definitely overlap with each other. But the central lowlands, we don't see some key physical features relatively recently, 3 million years ago, in the grand scheme of all the various maps that we've looked at for these various landform regions. This is a relatively new one. And even 25,000 years ago, when the continental glaciers were over the particular area here we're looking at, the central lowlands, what is today the Great Lakes and the Canadian Shield, the Hudson Bay and the Great Lakes, they weren't there. All those various lakes, the various 1,000 lakes of Minnesota, they weren't there yet. And so it was the continental glacier that created them. And we can see that today. Now that that continental glacier's gone, now that that white's been removed, then now we see the various 5 lakes, all the scattering of lakes throughout much of Canada and the big old Hudson Bay. And so as the glacier advances, it carves. And essentially what it does is it carves these deep troughs and essentially scours the land. And so we've got all of this old igneous rock, the Canadian Shield, very old ancient rock that essentially has been plucked and carried by this glacier and dumped to the front, like a conveyor belt, brought to the front of the glacier. But also as it does that, it essentially is using that debris to carve deeper and deeper as the ice, nature's biggest bulldozer, comes in and carves these troughs that then, as the glacier retreats, as we see 14,000, 9,000, 7,000, 4,000, as it retreats, that essentially the carvings that it's created are then filled with its own meltwaters from this retreating glacier over time. So essentially the Great Lakes of North America were formed from a continental glacier. They carved these deep troughs, these deep valleys, and left behind these areas that then were filled by their own meltwaters of these chunks and bits and pieces and lobes of this continental glacier. Here's another one of my very complex illustrations showcasing some of the key landforms created from the continental glacier and it melting. What we have here is we have the Rocky Mountains, the Missouri River, the Mississippi River, Ohio River, and the Appalachian Mountains. But wait a minute. The Appalachian Mountains don't go all the way over here. They're supposed to stop over here. We just showed that on the previous map. But what's going on here is the Appalachian Mountains actually used to go all the way over here. In fact, they went out, over here into Texas. But what caused them to be split? And key to understand that, once again, is our good friend, the continental glacier. And so as it advanced, it essentially stopped about where the Missouri River and the Ohio River are today, which is why they formed and why they're there, located there. This is the boundary of this continental glacier. And so essentially it stopped. But we got a massive amount of ice. Think about it, entire continent wide. I mean, think about how long it takes just to drive from one side of the Indiana to the other. Now, just think about the entire area, the entire central lowlands and Canadian Shield being all one thick sheet of ice, with that it is not only thick, we're talking a mile thick. So there's a big, huge amount of ice that then melts. Of course, it's going to fill the valleys, create the Great Lakes, all of that. But it's also going to fill the rivers and fill the crevices with a lot of fast-moving, but also a massive amount of discharge, a massive amount of water. And so what that did over time was that essentially separated the Appalachian Mountains from this rugged feature we find in eastern Oklahoma and parts of Arkansas. That was essentially created from this continental glacier some 20,000 years ago and then subsequently in melting.